Hi all, we are going to discuss about logic circuit design with KV mapping method. We are actually using this KV mapping method to draw this pneumatic or hydraulic circuits. So let's dive into it. Before that, what is a logical circuit and why is KV map used? There are other methods like classical algebraic method for simplifying this circuits. So why KV map method? Because when there is a signal conflict, we have to avoid that by the simplest method and in an efficient way. So KVM method is one of that method which is very efficient, very simple to create a pneumatic or hydraulic circuit. So it says that while the classic algebraic method of simplifying binary functions is useful for many simple cases, it becomes time consuming as the function become very complex. Yes, just like I said, the complex methods require many simple methods to draw. So a graphical design method using KVM is used to simplify intricate control problems. What are the control problems? It can be a single signal conflict, and it produces the simplest possible result. This method is generally much faster than the algebraic method. So initially when we draw a KV map, it contains large control variables in the algebraic or binary logic model, which can be in Boolean methods. So from the diagram, they can form a number of suitable Boolean equations. We can reduce it into some basic simple Boolean equations. They are mapped together and then minimized, applying the basic rules of set algebra. This gives a final control equation in its simplest form. So after some rearranging in this basic Boolean equations, we can finalize this final control equations in its simplest form. So these are the 7 basic steps involved in this KV map method. So initially we have to draw a position step diagram according to our requirement in this in the question, and after that prepare a signal flow diagram. After that plot a signal flow path. Then prepare KV map for each memory, that is each direction control where prepare a KV map, and for each auxiliary memories. In the next step, extend the presence of memory designation by infilling and form loops. The next step, we have to form loops in this in the dedicated memory KV maps and extract the minimized memory sets and reset the equation or the reset it into the minimized format and construct the circuit finally. So now we can try out a question. Consider an automatic drilling machine. The complete cycle is as follows. First, initially, the cylinder A extends to clamp the workpiece, and then cylinder B extends to drill a hole in the workpiece, and then it retracts. And cylinder A then retracts to the and clamp the workpiece. We have to design a control circuit using KV method for this. So we know in the first step we have to draw the position step diagram. In the right side you can see this position step diagram. How it is drawn, like from the question we know that initially the cylinder A get extended to clamp the workpiece and can be denoted as A plus or A1. Initially it is in rest cylinder A, then it goes to extended state. After that B extend to place the driller and the drilling action is done there. After the drilling action is completed, the B get retracted and it rests there. All this time the extended cylinder A clamps the workpiece in the required position. After the B retracts, A also retract to unclamp the workpiece. So that's how we can draw a position step diagram from the question. The next step is to draw a KV map. How can we draw a KV map? We have to draw a KV map by horizontal and vertical lines. So how many horizontal lines required can be from 2 raised to n or 2n. N is the number of cylinders. So we have two cylinders here, cylinder A and cylinder B. So we need 4 horizontal lines in KV map. These horizontal lines on the map represent all the possible position sequence value combinations. Hence their number is determined by this 2n equation. These vertical columns represent auxiliary memory outlets and their number is defined by the signal flow path. And by step transfer, all the position sequence value combination is transferred into the prepared KV map and the signal flow diagram is obtained. So this will be how a signal flow diagram or KV map looks like. So when we look at this KV map, we can see there are 3 columns in this. So when we look at this KV map, the first 2 columns are taken like that by convention. So in any question when we have 2 cylinders, the first column will be B0, B1 and second column will be A0, A1, A1, A0. It is taken by convention just like this. Values from the fields are from the position step diagram and the first 2 columns. So when we look into this, we can say there is 2 positions included in a field, which is not allowed. In a field, only one memory designation should be occupied. If a memory designation falls into an already occupied field, the map must be enlarged to twice the existing number of columns. If you have only one column, we need to extend another column. If you have 2, we need to extend it into 4. So we have here one column and it have 2 positions included in a single field. So we need to expand it into 2. The new column represents the auxiliary memory. The memory designation A which fell into already occupied field will be moved into the new column, and also preceding memory designation B into the new column. So the memory designation which represented here is this A0 is moved into the next column. Also the preceding to A0 is B0, which will be also moved into the new column, the auxiliary memory column we created. This A0 is moved into the next auxiliary column and B0 also, and it is represented as X and X bar. New columns are represented as X1 and X0, and from this we can write the equations for respective fields. For example, like I have written here, for B1 we can write like B0 A1 X bar. Similarly, we can write equations for all other fields. We can see there is too many equations here, which will be difficult for us to create a efficient and minimized logical circuit. So in the next step, we have to minimize the logic equations. So to minimize the logic equations, individual K-maps are drawn for each memory that appear in the signal flow diagram. So in signal flow diagram, we have 3 memories A, B and X. So we need to draw separate K-maps for all these. For example, we take this memory A and label the appearance of a signal A1 to A1 and A0. A1 and A0 are marked separately. That is, the circles are shaded where A1 is present and unshaded for the circles for A0. And the presence of A1 is extended as far as possible along the signal flow path until it must disappear to allow signaling by A. And a loop is drawn around the circle which indicates the presence of the signal, say A1 and A0. So we can see in this figure that a loop is drawn from for A1 and A0. So there are certain rules for this. The unoccupied fields like B, A, X may be included in this loop. We can also include this unoccupied fields in this loops. The number of fields encompassed by this loop must be a power of 2. We can only include the loops in loops or in the field in this loop only as a power of 2. That is, it may be 2 or 4 or etc. like that. The loop must be symmetrical shape. This loop have to be symmetrical. No U loop or L loops or other asymmetrical loops are not allowed. And draw loops as large as possible to include more fields. This produces shorter logic equations and fewer and or logic elements. So at the end we have to reduce this logic circuit into its simplest form. So include as more fields as we can. It will in turn reduces this shorter logical equations and the circuit become more similar. So in the similar way we can draw for memory for B and memory X. So looking at this memory value, we have included this four fields in this. We know that we can only include fields or group the fields in a way that it will be a power of 2. So here considering this A1, we have this 4 fields in this format. We have also included an empty field. Similarly we have for this A0 also. Why don't we included this? Because it is not allowed to include any, we cannot loop anything like in a L-shaped or U-shaped. We also said that we shaded this A1 as in darker and A0 as unshaded. It is not necessary to shade this if you can understand how to loop initially. Then after that we have to write this Boolean equation for every field in a loop. So considering this A1, we can write 4 Boolean equations like B0 A0 x bar, B0 A1 x bar, and B1 A1 x bar, B1 A0 x bar. There is the next step is to reduce it into a simplest form. So after looping the logic equation, we wrote it in according to this each field, and the variable that changes their binary value 0 to 1 within the loop render the other values and result in the dropout of the equation. That is, we can see that this B0 changes to P1 in this loop. Inside this loop we can see that B0 is changing its value to P1 in the same loop. Also this B0 is changing it to the P1, and this A0 to A1 and A1 to A0 or A0 to A1. So this changing value is considered as valueless and they drop out of this equation, and at the end we get A1 equal x bar. That is a final equation. So how can we write this for A0? For A0 we have two equations, right? B0 A1x and B0 A0x. So this B0 A1x and B0 A1x have only one changing character, which is A0 into A0 A1. So what will be the final equation for A0? It will be B0 x, right? Okay, so similarly we can also write for memory value B and memory value X. So at the end we get how many equations? Two equations for memory value A and two equations for memory value B and two for X. So these are the final equation. With these equations we can draw the logic circuit. Also please look into this memory value X. We have looped it like in this manner, which is also okay. We can include power of 2, and also this is not any L or U shape. So that's it, and that way we can draw our logic circuit from the equations we got. Try to draw it by yourself from the equations, and you may feel it like a little bit complex, which actually it is very simple when you try to understand the concept and try to draw it 1 or 2 times yourself. Thank you.